Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on unit normal vector with respect to the scalar function xy plus yz plus zx equal to c at the point -1, 2, 3. How to represent the unit normal vector and how to find the solution at the point of -1, 2, 3. Now, let us see. First, let us represent the given scalar function, that is given phi, which is equal to x y plus yz plus zx minus c. Oh, sorry, zx minus c. Always, if we are representing any function or the equation, it should be equal to 0 with respect to phi. If we are representing phi means, that is, let us define, that is, always see, if they have given yx xy plus yz plus zx equal to c. To define this scalar function, it should be always, the equation should be equal to 0. So what I am going to do, xy plus yz plus zx minus c equal to 0. Now we can represent this as scalar function phi, that is xy plus yz plus zx minus c. Now this is the scalar function which is the given function. Okay. Now I need to find unit normal vector. What is unit normal vector? Where unit normal vector is defined by n cap, which is equal to gradient phi divided by modulus of gradient phi. At the point, what is gradient phi? Gradient phi defines dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Differentiating the scalar function phi with respect to x, y, z with respect to direction I, j, k. At the point, now let us differentiate gradient phi, which is equal to dou by dou x. What is phi? We have xy plus yz plus zx minus c I cap plus dou by dou y into xy plus yz plus zx minus c j cap plus dou by dou z into xy plus yz plus zx minus c into k cap. Differentiate the term, differentiate this e function with respect to term by term. Okay, how to differentiate? Now let us see. First, I need to differentiate this whole function with respect to x. So what I'm going to do, consider gradient phi, which is equal to, let us differentiate term by term. Okay, first term, in this x and y, see x and y, we have x, so y remains constant. Differentiation of x is 1 with respect to x is 1 into y is y. Here we don't have x. If there is no variable x, that means there will be 1 differentiation with respect to x is 0. So this term becomes 0 plus z remains constant. We have x, differentiation of x is 1 minus constant term is 0 into I cap plus, similarly go with respect to y. In this first term by term, x remains constant, differentiation of y with respect to y is 1 plus, we have y. Now see the second term, we have y and z. We have y, I can differentiate with respect to y, so differentiation of y is 1, z remains constant. Here we don't have y, so this term becomes 0. This term becomes also constant term also 0 into j cap plus the last. See, in the first term we don't have z, so the first term becomes 0. Next, in the second term we have z. So y into differentiation of z is 1 plus we have z in the first in the third term. So differentiation of z is 1. The remaining terms will be constant. That is x minus 0 into k cap. Got the point? Yes. Gradient phi, which is equal to y into 1 y plus z into 1 z I cap plus x into 1 x plus z into 1 z 0 minus 0 0 j cap plus y into 1 y plus x into 1 x k cap. Got the point? Now this is our function, what, gradient phi. For this gradient phi, I am going to apply the points at minus 1 2 3. That is at the point minus 1 comma 2 comma 3, where x equal to minus 1, y equal to 2 and z equal to 3. Now just substitute gradient phi, which is equal to, what is the value of y, that is 2, plus what is the value of z, that is 3, into I cap, plus what is x, we have minus 1, that is what is z, we have 3, into j cap, plus what is y, we have 2, plus of what is x, we have minus 1, into k cap. Now gradient phi, which is equal to 2 plus 3 5 I cap plus minus 1 plus 3, you get 2 j cap, plus into minus minus 2 minus 1 1 k cap. This is our gradient phi. Now let us find modulus of gradient phi, where modulus of gradient phi is defined with respect to square root of this term with respect to ijk direction, that is 5 square plus 2 square plus 1 square. It is gradient phi, which is equal to 25, 5 square is 25, 4 square 1, sorry, 4, 2 square is 4, 1 square is 1. That is gradient phi, which is equal to 25 plus 4 29, 29 plus 1 30, root 30 is the solution for gradient phi. But we need to show that find unit normal vector of the given function. What do we have unit normal vector? We have defined unit normal vector as where unit normal vector is given by n cap, which is equal to modulus, sorry, gradient phi divided by modulus of gradient phi. What is gradient phi? We have 5 I cap plus 2 j cap plus 1 k cap divided by modulus of gradient phi, we have root 30. This is our required unit normal vector of the given scalar function, that is xy plus yz plus zx minus c at the point minus 1 comma 2 comma 3. I hope you have understood this problem step by step, how to find the gradient phi, how to differentiate with respect to x, y, z, easiest method. For more videos, please do like, share and subscribe. See you in the next video. Thank you.